Good evening, everyone. Today I'm going to explain all the properties of rational numbers to you all. So today I'll explain briefly about closure property. So first we need to equate closure property. First we need to understand the three types of numbers. So that's three types of numbers. So there's integers, whole numbers, and rational numbers. So or positive number. So 1, 2, 3, infinity. Integers are numbers that are less than 0 or negative numbers. So 0 here, -1, -2, -3. And rational numbers are just fractions. For example, 1 by 3, 1 by 2, 1 by 5, stuff like this. So I'm going to explain how all of these number types apply with closure property. So first we'll start with whole numbers. So let so closure property is something that, and when you equate two numbers together, for example addition or subtraction, you're supposed to get the same number type. So for addition, you can say 1 plus 1 plus 2 is equal to 3. 1 is a whole number and 2 is a whole number, and so OL is 3. So addition is closed under closure property. Now we look at something like subtraction. So for this example, we'll take the numbers 5 minus 7 is equal to -2. -2 is an integer, so it doesn't come under closure property. So this does not. Now we'll take multiplication. So like this, we'll take 7 into 5. 7 into 5 is just 35. So here it's a whole number. So as you can see here, yeah, I multiplied two whole numbers and I got a whole number with it. Okay. Now we'll look at division. So 8 divided by 5 is equal to 8 by 5. So this is just a rational number. As you can see, this just turned into a fraction. So this doesn't come under division. So that's basically the simple. So that's it simplified. Pardon?
So yeah, Naribal.
Now we're going to see if the same closure property applies for integers. So integers are a little bit different. So as you all know, it's numbers before 0. So like -1, -2, and -3. So first we'll look at addition. So if we take two integers as their face value, for example -5 less 3, the answer is going to be -2. So here we have an integer, so this checks out. For subtraction, on the other hand, we can take the same example. So -5 minus -3. So this in turn will be -8. So this as well checks out. Multiplication. This is a tricky one, but then you just have to apply the bigger numbers sign. So as you can see here, 8 into 5. So the bigger number here is 8, and you just multiply these on their face value. 8 times 5 is 40, so that's going to be -40. So this as well checks out. It's an integer, that's it. Now division. Division, you can just take the same example. -8 divided by 5. This, however, does not, as again it turns into a rational number. So this does not check out. So now we're going to look at the same thing but with rational numbers. So first, for addition we can take 1, sorry, not 2, sorry, not 3, but 2. As you can see, the denominators are same, so we just have to equate the numerators. So that's 3 by 2. So this is also a rational number, so this checks out. And also to clarify, everything which is a fraction is always going to be a rational number. So now let's look at the same thing but with subtraction. So 2 by 2 -1 by 2. The obvious answer is just going to be 1 by 2. So this also checks out. But for multiplication, it's a different story. So if we have 2 by 3 into 3 by 6, this gets a little bit complicated. So first, we have to cancel the numbers out. So 3 and 3 cancel each other out. 2 and 6 cancel each other out. This is going to be 1, and this is going to be 3. So the final answer is 1. 1 times 1 is just 1. 1 times 3 is just 3. So the final answer is 1 by 3. So this as well checks out. But for division, it's quite a different story. For division, there's a method called reciprocal. So I'll show you what that is. If you take a number in its face value, like 2 by 3, as you can see, we don't just divide it like this. We don't just equate it like this. You have to flip this number so that it becomes 1 by 2 multiplied by 3 by 2. Yeah, 3 by 2. Now we just multiply the following. So 1 times 3 is just 3, 2 times 2 is just 4. There you go. all of this as well checks up. This is true for everything except 0.